Stop prompt injections before they break your model. By the end of this video, you will have a simple Python guard you can run on incoming chat. You will see how to flag risky inputs, score them by severity, pick the single riskiest one, and apply a tunable threshold to block or allow messages. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced in simple Python. Prompt injection and jailbreak attacks matter because they overrotted your instructions. That directly harms safety and reliability. A good guard improves robustness, which you can measure as fewer successful instruction overrides. The trade-off is precision versus recall. Stricter checks reduce successful attacks, but increase false blocks. On a corpus of a few thousand messages, a simple keyword guard often catches the obvious patterns while keeping latency negligible. The intuition is straightforward. Look for words or structures attackers reuse. Give those words weights based on how dangerous they are. Combine presence checks with small rules for structure and you get a fast, explainable filter. This shines when you need low latency and auditable decisions. Its limitation is obvious. Clever attackers will paraphrase, so this is a first line, not the only line. We will build a short pipeline that detects classic injection phrases, ranks messages by risk, selects the worst offender, enforces a threshold, and then uses a combined keyword and structural rule to omit allow or block labels. This snippet flags messages containing classic injection and jailbreak phrases. It shows a list named MSGs holding short user inputs we want to screen, and a list named bad that defines risky tokens we do not want models to follow, such as the words ignore and SDAN. The comprehension walks through MSGs with enumerate, lowercases each message, and checks whether any risky token appears. Matching positions are collected into flags so you get the indices where suspicious content appears. The printed positions give immediate actionable signals about which messages might override instructions and should be blocked or reviewed. Now we will add simple severity weights to each keyword. This snippet assigns simple risk scores to each message using weighted keywords. The same list messages appears as the inputs, and a dictionary W maps each risky token to a severity weight. For every message, the logic sums the weights for tokens found in its lowercase form, producing a numeric score aligned with each message. Higher scores mean stronger evidence of instruction override attempts or jailbreak patterns. The printed list of scores gives a direct and comparable risk measure for each input, which helps prioritize automated or manual handling based on relative severity. Next, we pick the single riskiest message for immediate attention. This snippet selects the single riskiest message index using score-based ranking. It uses the same messages and weight dictionary to produce scores with the same summation logic. The code then calls the function max, which returns the largest element based on a key to find the index whose score is greatest. Using scores.get as the key lets the selection compare by value instead of by index. The printed index is a clear candidate for blocking or escalation and gives you one immediate mitigation target when you need to act quickly. Now we will turn the scores into a hard pass or fail using a threshold. This snippet blocks messages at or above a tunable risk threshold called tau. The messages and weights produce scores exactly as before, and then a comprehension keeps only indices with scores meeting or exceeding tau. That makes a crisp pass or fail decision. You can plug into a guard pipeline or an API layer. Adjusting tau changes behavior. Raising tau makes the guard stricter about evidence, which reduces false positives but may miss subtle threats. Lowering tau will block more messages, which catches more risks but increases overblocking. The printed indices show which items are currently denied by that threshold. Finally, we combine keyword checks with structural heuristics for a compact verdict. This snippet combines keyword and structural checks to produce allow or block decisions for every message. The list messages includes inputs and a code-styled message meant to trigger structural heuristics. The logic constructs hits that mark any message matching risky keywords or containing structural tokens such as triple backticks, base 64, ROT13, or explicit system prompt phrases that often appear in injection setups. A final comprehension converts those Boolean hits into human-readable labels like allow or block, so you can wire them into a policy. The printed labels give a short moderation verdict for every message in order. Recap: this is a lightweight keyword and structure guard that flags and scores risky inputs. Use it when you need low latency, simple audit trails, and quick mitigation. Caveat: it is not a substitute for semantic or model-based defenses because clever paraphrases can evade it. Next step: tune the keyword weights and the threshold tau while testing on a larger corpus so you can plot blocked rate versus false positive rate. That single change will let you trade safety for utility in a controlled way. If practical AI engineering helps you, subscribe and watch the AI engineering videos.